Hi, I'm Chad Wunderlich with Viking Pump, and if you've missed any of our videos about pump operation, you're in luck. We're going to be revisiting our various rotary PD pump technologies, and today we're going to start with the internal gear pump and where they're used. You're watching the Pump Report. Viking Pump founder Jens Nielsen invented the internal gear pump over a century ago. This simple design features only two moving parts, a drive gear called a rotor, and a driven gear called an idler. The rotor is an internal gear with its teeth pointed inward. The idler gear is an external gear and has fewer teeth than the rotor, creating an offset between the gears. A crescent on the head of the pump separates the two gears, creating a series of pumping cavities between both the rotor and the idler. And here's how it works. The liquid enters here, at the suction port, between the teeth of the rotor and idler gears. As those teeth come out of mesh, a low pressure zone is created and the liquid is pulled into the spaces between the teeth. The liquid continues to travel through the pump with the rotation of the gears and is prevented from returning to the suction side because of the crescent acting as a seal between the suction and discharge sides. At the discharge port, when the gears mesh completely, the liquid is forced out of the spaces and into the downstream piping. Internal gear pumps are used in a wide variety of applications because they're suitable for a wide range of viscosities and come in a variety of sizes and constructions. Some of the most common applications include asphalt, adhesives, and chocolate. The internal gear pumps can be opposite ported like our animation showed, or right angle like our display pump. They can also be designed to operate in either direction rotation, changing the direction of flow with the direction of rotation of the gears. To learn more about internal gear pumps or to view other pump reports, please visit our website at vikingpump.com.